Alright, we're going to be graphing this basic quadratic function f of x is equal to x squared. And I just want to remind you that f of x means the same thing as y. If you do not feel comfortable seeing the f of x, the function notation, you can replace it with a y. Interchange it with a y, it means the same thing, it's alright. Okay, let's start figuring out what we're going to plug in for x. I'm going to plug in -2, -1, 0, 1, and 2 so we can get some y values. Let's start off with substituting -2 for x. Every time I see an x in my equation, I'm going to be substituting a -2. So let me erase that x and let me rewrite a little -2 in there. So f of -2 is equal to -2 squared, which is -2 times -2, and that's going to equal a +4. Okay, let's do f of -1. F of -1 is going to just be -1 squared. And -1 squared is just -1 times -1, which is going to give me a +1. F of 0 is going to be equal to 0 squared, but since 0 squared is just 0 times 0, we're just going to get a 0 right there. And f of 1 is going to be 1 squared, and 1 squared is just 1 times 1, which is 1. And last here we have 2, right? So we're going to have f of 2, which is going to be equal to 2 squared, which is just 2 times 2. And that's going to give me a 4. So we have 5 sets of ordered pairs. I'm going to take these ordered pairs and I'm going to plot them on my graph so I can get a sketch of the graph of f of x is equal to x squared. And there is my sketch. I'm going to label each point because I like how it looks when I label each point. This point right here, 0, 0, this is a special point on our graph. This is called the vertex. And this particular graph has a special name. It's called a parabola. If you notice, the parabola is symmetrical. There is this imaginary line of symmetry, goes down the very middle right through the vertex. And this we call this the axis of symmetry. The equation of this line is x equal to 0. It's always going to be the x value of your vertex. So every single point on the left-hand side of the axis of symmetry has like a mirror image across the axis of symmetry on the right-hand side of it. Imagine if I took a piece of paper and I folded it right at the axis of symmetry, every point would fall right on top of another point, the mirror image of it. That's why negative 1, 1 is exactly the same distance from the axis of symmetry as 1, 1, and negative 2, 4 is the same distance from the axis of symmetry as 2, 4. Okay, I'm going to be referring to this graph right here as the parent graph in future videos. I'm going to be referring to it a lot. I suggest you memorize it. Notice that from the vertex to go to our next point here, notice I went over left 1 and then up 1, and then I went over right 1 and then up 1. To go over to our negative 2, 4 from our vertex, we went over 2 to the left and up 4. And to go to the vertex to the 2, 4, we went over 2 to the right and up 4. So I will be referring to this pattern also. So it's a good idea to memorize that little pattern right there. Okay. Alright, that's going to be it for this video. Okay, the next video is going to be graphing quadratic functions part 2. So make sure you watch that one after this one.